Jimmy Akin's Mysterious World is brought to you by the Star Quest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give. You're listening to episode 91 of Jimmy Akin's Mysterious World, where we look at mysteries from the twin perspectives of faith and reason. In this episode, we're talking about the government conspiracy to push the dangerous chemical hydroxylic acid on the public. I'm Dom Bettinelli, and joining me today is Jimmy Akin. Hi, Jimmy.
Howdy, Dom.
Folks, since ancient times, alchemists and natural philosophers have known about hydroxylic acid. It's one of the most powerful solvents ever discovered, and as a result, it's very dangerous and has numerous harmful properties. Although they knew it dissolved many things, it wasn't until 1781 that the English scientist Henry Cavendish discovered the chemical makeup of this acid. But despite its dangers, a bizarre health craze has developed, with many self-proclaimed health gurus telling people that they need to consume hydroxylic acid. They've even influenced the government to put it in our water supply, even though most people have no idea whatsoever that they're drinking a powerful acid. What is hydroxylic acid? What do we know about it? What health effects does it have? Who's behind this government conspiracy, and how should we respond to it? That's what we'll be talking about on this episode of Jimmy Akin's Mysterious World. So, Jimmy, how long have people known about hydroxylic acid?
It's hard to say. Some knowledge of it certainly goes back into prehistory, though, of course, they didn't understand it nearly as well back then. They just knew you could dissolve stuff in this acid. The ancient Egyptians knew about it. They even had a special word for it. They called it mu. Though because they wrote their language without vowels, there's a debate about how it should be pronounced. Most likely it was either mew, like the noise a cat makes, or moo, like the noise a cow makes. Their knowledge of it was limited, as it was for other substances. For example, they had a substance that they found in the desert called natron. Today, we know that natron is a combination of sodium bicarbonate and sodium carbonate, so a combination of baking soda and soda ash. But the Egyptians didn't know that. They just knew that it absorbed a lot of water, and so they used it in the mummification process to dry out mummies. In fact, they would bury a body in natron for 70 days to dry it out so that it would last through the centuries. And that there's actually a neat little bit of confirmation for the Bible in that, because when the patriarch Jacob dies, they mummify him with the Egyptian rites, and the Bible notes it took 70 days. The Egyptians called hydroxylic acid mu or mu, and the name for it was similar in other ancient Near Eastern cultures. In Ugarit, it was called May. The Canaanites called it Mima. The Hebrews called it Mayim. And the Akkadians called it Mau, or just Mu. The Greeks also knew about it. You know, they were big on natural philosophy, like with Aristotle. But since the language that they spoke belonged to a different language family, their word for it sounded different. They called it Hudor.
So how did ancient scholars study hydroxylic acid?
As we talked about in episode 79 on religion, magic, psychic phenomena, and science, these disciplines were all intertwined with each other in the ancient world. The modern concept of science hadn't yet developed, so what we think of as natural science was then called natural philosophy or even natural magic. At the time, chemistry was the same thing as alchemy, and it was all bound up with religion. In the 300s BC, Alexander the Great conquered most of the known world, including Egypt, and this led to a fusion of Greek and Egyptian culture. Now, in Egypt, one of the main gods of magic was Thoth, and one of the Greek gods of wisdom and magic was Hermes, or as the Romans called him, Mercury. In the Greco-Egyptian imagination, Thoth and Hermes blended into one, and a body of religious and philosophical thought grew up around this figure, and that school of thought is known as Hermeticism. Eventually, they started referring to this figure as Hermes Trismegistus, or the thrice great Hermes. He's 3 times great. Some in the early church even thought that Hermes Trismegistus was a wise pagan prophet who foresaw the coming of Christianity. Hermeticism became very popular in the ancient world. If you've ever heard the maxim, as above, so below, that comes from Hermeticism. And Hermeticism inspired a lot of ancient alchemy. The alchemists were definitely aware of hydroxylic acid, and they even had a special symbol for it, which looks like a downward pointing triangle. We don't know the names of a lot of the earliest alchemists, but the first one who we do know by name was called Mary the Jewess. And as you would guess, she was a Jewish woman named Mary. She lived around AD 200, and she was quite interested in hydroxylic acid. In fact, she invented a special device that involved a bath of hydroxylic acid, and it's still used in chemistry today. Based on its name in the French language, it's called the Bain Marie, or the Bath of Mary.
So did people in this era know that the acid could be dangerous?
Oh, yes. Alchemists knew that hydroxylic acid is an extremely potent solvent. It will dissolve many kinds of inorganic matter, like minerals, as well as organic matter, and naturally it can have negative effects on humans. In fact, in the Middle Ages, it was sometimes used as a means of torturing people and even executing them. This happened at least as far back as the 1400s. For example, the French poet and criminal François Villon was tortured with the acid in 1461. And in the 1600s and 1700s, it was used extensively in French courts. They would refer to this form of torture as being put to the question, with the act being classified either as an ordinary question or an extraordinary question. If you were put to an ordinary question, they would force 1 gallon of the acid down your throat and into your stomach.
Oof.
And if you were put to an extraordinary question, they'd force down 2 gallons. Naturally, the victims of the torture would vomit immediately to try to get rid of the acid, but then the torturers would just start over. A similar method was also reportedly used by the Spanish Inquisition, though, as always, we have to be careful about claims about the Spanish Inquisition since it was the subject of a lot of false rumors. Allegedly, in 1620, a Scottish man named William Lithgow was traveling in Spain, and the Spanish thought he was a spy. So they applied the torture to him, at least that's what he says in his book, Rare Adventures and Painful Peregrinations, which he published in 1632. According to him, the acid caused, quote, a suffocating pain, close quote, and it, quote, re-engorged itself in my throat with a struggling force. It strangled and swallowed up my breath from yowling and groaning.
Wow. All right, so people knew this acid could be really harmful to the body even before we learned more about it with the development of modern science then.
Yeah, as we mentioned in the introduction, in 1781, the English natural philosopher Henry Cavendish did a bunch of work and was able to figure out its basic chemistry, though even he didn't learn everything. Some of what he proposed were just guesses. But he did find that a good part of the acid is made from a substance that he named inflammable air. Now, that may sound safe because of what you would think inflammable means, but remember, inflammable means capable of being put in flames, so it really means flammable. So it's a kind of air, inflammable air is thus a kind of air that will burn, giving you a sense of how dangerous hydroxylic acid can be if you separate out its individual components.
Where did Cavendish get his hands on hydroxylic acid to study?
Today, we can make it in a lab, but back then, they had to find it in nature. And there's an interesting story behind that because we now know that Earth did not originally have hydroxylic acid. When the Earth was forming, it was far too hot, and the high temperature would decompose or destroy the acid. Consequently, all of the acid we have here on Earth today came later from extraterrestrial sources. The current best guess is that most of the hydroxylic acid on Earth was brought here by planetesimals that collided with Earth after its surface had cooled enough to allow the acid to exist.
So hydroxylic acid exists in space?
Yeah, and it appears from modern studies that there's rather a lot of it out there. You know how we found weird exoplanets that have really weird kinds of rain?
Sure.
For example, we found a planet called HD 189733b where it rains glass. And it rains the glass sideways because the winds whip around the planet at 5,400 miles an hour. So you'd be cut to ribbons by the flying glass rain if you went there. We've also found a planet called Korot 7b, which is so close to its star that it's hot enough to vaporize the silicate rock on its surface. And that means that as weather fronts move around it, the vaporized rock in the atmosphere condenses into pebbles and it rains into lakes of molten lava. We've also found a planet called HAT P7b, which looks like it has winds blowing around rubies and sapphires. In the further resources for this episode, we'll have a link to stories about how it rains on different planets, including planets where we think it rains sulfuric acid, glass, diamonds, iron, and methane. Well, it turns out there are also strange planets where there are great clouds of hydroxylic acid in the atmosphere, and it literally rains out of the sky. Actually, we found one planet in the constellation Ophiuchus, the serpent carrier, known as Gliese 1214b. And it appears that most of this planet is made out of hydroxylic acid, at least 75% of it, and maybe all of it. So, what a strange world that is.
Yes, okay. But back here on Earth, we said that there's been a health craze about the acid in recent years. What can you tell us about that?
It's like a lot of health crazes. I should point out that personally, I don't have a problem with alternative medicine. I know from personal experience that some alternative treatments work, and we'll talk about that in future episodes. But I also have a healthy respect for conventional medicine, and there is an awful lot of snake oil being sold today that isn't backed up by science and that can have really unexpected and unintended consequences.
Can you give us an example of that? One where people have suffered as a result of alternative health treatments?
You bet. One example is a condition known as carotenosis. Vegetarians sometimes come down with this. You may remember that periodically there's been a health fad for drinking carrot juice, which is very high in carotenoids, including beta-carotene, which is a type of vitamin A. Well, if you consume enough carotenoids, they will build up in your skin and turn it yellow-orange. And it doesn't have to be carrot juice. It can be other juices and foods as long as they're high in carotenoids. The good news is that this condition will wear off and your skin will go back to normal once you lay off the veggies. But it still impacts your quality of life if you turn orange for a while. An even more dramatic condition, and this one doesn't wear off, is caused by the health craze for colloidal silver. We've known for a while that various metals have antimicrobial properties, meaning they kill microbes. And that's why you see a lot of copper doorknobs in public buildings. It's also why water pipes in buildings are often made of copper, because it helps kill the germs in the water supply. Well, another metal that has that property is element 47, or silver, which has led to the health fad for colloidal silver. In chemistry, a colloid is a system of really tiny particles suspended in another medium. So the idea is you dissolve a bunch of silver into nanometer-sized particles suspended in a liquid, typically distilled water, and then you drink it. People can buy homeopathic preparations of colloidal silver, and you can make it at home with some silver wire, distilled water, and a battery. In recent years, it's been really popular, and people have been claiming it has all kinds of health benefits. But if you take too much, it also has a horrible side effect. Here's a passage from Sam Keen's excellent book on the periodic table, The Disappearing Spoon.
There is an ostensible scientific basis for using silver since it has the same self-sterilizing effects as copper. The difference between silver and copper is that silver, if ingested, colors the skin blue permanently, and it's actually worse than that sounds. Calling silvered skin blue is easy shorthand, but there's the fun electric blue in people's imaginations when they hear this, and then there's the ghastly gray zombie smurf blue people actually turn. Thankfully, this condition called argyria isn't fatal and causes no internal damage. A man in the early 1900s even made a living as the Blue Man in a freak show after overdosing on silver nitrate. In our own times, a survivalist and fierce libertarian from Montana, the doughty and doughy Stan Jones, ran for the U.S. Senate in 2002 and 2006 despite being startlingly blue. To his credit, Jones had as much fun with himself as the media did. When asked what he told children and adults who pointed at him on the street, he deadpanned, "I just tell them I'm practicing my Halloween costume." Jones also gladly explained how he contracted argyria. Having his ear to the tin can about conspiracy theories, Jones became obsessed in 1995 with the Y2K computer crash, and especially with the potential lack of antibiotics in the coming apocalypse. His immune system, he decided, had better get ready, so he began to distill a heavy metal moonshine in his backyard by dipping silver wires attached to 9-volt batteries into tubs of water, a method not even hardcore silver evangelists recommend, since electric currents that strong dissolve far too many silver ions in the bath. Jones drank his stash faithfully for 4.5 years, right until Y2K fizzled out in January 2000. Despite that dud, and despite being gawked at during his serial Senate campaigns, Jones remains unrepentant. He certainly wasn't running for office to wake up the Food and Drug Administration, which in good libertarian fashion intervenes with elemental cures only when they can cause acute harm or make promises they cannot possibly keep. A year after losing the 2002 election, Jones told a national magazine, "It's my fault that I overdosed on silver, but I still believe it's the best antibiotic in the world. If there were a biological attack on America, or if I came down with any type of disease, I'd immediately take it again. Being alive is more important than turning purple."
So you can see how true believers like Jones are willing to overdose on silver, even though it turns them a ghastly grayish blue and affects their quality of life. Now, we should note that the colloidal silver is supposed to be an antibiotic, meaning it helps with bacteria. It won't help with viruses. These are just two examples of the carotenoid, the carrot juice drinking and the colloidal silver drinking are just two examples of modern health crazes run amok. Fortunately, both of these are ones that don't actually kill people, but taking too much hydroxylic acid can.
Let's talk about this health craze for this acid then. What does it involve?
Okay, like always, I want to be scrupulously fair here. So I'll start by admitting that there are valid medical uses for hydroxylic acid. There are limited circumstances where if you take the right amount of hydroxylic acid, it can help you. In fact, the World Health Organization has a model list of essential medicines that includes hydroxylic acid. If you want to look it up, it's listed as an essential medicine under classification 26.3 on page 33 of the 2013 report, which we'll have a link to. It can be used as an injectable and shot under the skin into a muscle or into a vein, but you have to be really careful with it. For a start, it and any other substances it's mixed with needs to be sterilized to get rid of impurities. Also, it often needs to be mixed with other substances to make it more or less isotonic, which deals with how much pressure it puts on cells. If you don't do that and you inject it into a vein, it can cause hemolysis, which means it can cause your red blood cells to break down. That can result in kidney problems, and taking excessive amounts can lead to fluid overload. In fact, hydroxylic acid, if you don't mix it with certain other substances, it can be completely useless for health purposes. So you have to be really careful with it. Back in the 1500s, there was a Swiss physician, alchemist, and astrologer named Theophrastus von Hohenheim, or as he's better known today, Paracelsus. He was a very famous figure in the medical revolution of the Renaissance, and Paracelsus today is known as the father of toxicology. One of the things he's famous for in toxicological circles is the Latin phrase sola dosis facit venenum, which is often translated as the dose makes the poison. Technically, what he said was all things are poison and nothing is without poison. The dosage alone makes it so that a thing is not a poison. So the idea is if you take a small enough amount of anything, it's not going to hurt you. But if you take too much of anything, it is going to hurt you. And he pointed out that even things we need, like water and oxygen, can become toxic in the right doses. So modern toxicology measures how harmful something is based on what's called the median lethal dose. This is also called the LD50, LD standing for lethal dose, and the 50 indicating that if this dose is administered, 50% of the test subjects will die. So LD50, you give someone that much of something, and that if half of them will die. We do not know the median lethal dose of hydroxylic acid in humans because obviously it would be immoral, unethical, and illegal to administer it to people to see how much of it will kill 50% of the human test subjects. However, the LD50 for hydroxylic acid has been found for other creatures, such as laboratory rats, who don't enjoy the same legal protections that humans do. It turns out that for a typical laboratory rat, all they need is 34 grams to achieve 50% lethality. And 34 grams is not a lot. It's only 1.2 ounces in the English imperial system. Now, here's the problem. We do not know what the medium lethality dose of this acid is for humans, but the devotees of the health craze are recommending that people consume huge amounts of it, even without that being backed up by scientific studies. Some of them claim that it's okay to consume as much as 3.8 kilograms of it within a 24-hour period. And like I said, that number is not backed up by any scientific studies. The idea that that level is desirable or safe is a pure invention of the health rumor net. What's especially frightening is that there is even a known psychological condition known as psychogenic polydipsia that causes people to become psychologically addicted to introducing large amounts of this acid into their bodies.
So what happens if you take too much?
We already mentioned that if you introduce it into the bloodstream in the wrong way, it can cause your red blood cells to break down through hemolysis, and that can lead to kidney problems. Regardless of how it gets introduced into the body, one of the first things it will do if you take too much is raise your blood pressure. It also overtaxes your kidneys. Your body is trying to process the hydroxylic acid to get rid of it, but your kidneys can only do that so fast. And if you take too much of it, they can't keep up, and it starts building up in your bloodstream and tissues. The crucial role of the kidneys also means that people with kidney disease are particularly susceptible to hydroxylic acid toxemia. It also can cause a condition known as dilutional hyponatremia, in which your body can't use sodium or other electrolytes effectively. This is especially a danger for children under 1 year of age due to their small body mass. It's also a danger for athletes, and especially marathon runners. Even if they try to beef up their electrolytes with sports drinks, they can't process enough of them. So this condition, dilutional hyponatremia, occurs in about 20% of people admitted to the hospital and 10% of people during or after an endurance sporting event, like running a marathon. In fact, medical personnel at marathons are specially trained to watch for this condition. And it's estimated that hyponatremia has an economic cost of $2.6 billion each year in the United States. Also, some users of recreational drugs like MDMA are prone to this condition. And the condition can even be caused iatrogenically, meaning medical professionals cause it in their own patients when they mismanage doses of hydroxylic acid. For example, doctors have been known to cause it in patients who have been nasogastrically intubated so they can be fed through a tube. It's also associated with certain neurological and psychiatric medications like oxcarbazepine, and it can easily be created in patients with diabetes insipidus.
What kind of symptoms do people present when this happens?
If it's a mild case, the symptoms can include lack of concentration, headaches, nausea, and poor balance, so people can fall over and hurt themselves. More severe symptoms include confusion, seizures, brain damage, and coma. It can even lead to death. People have died as a result of hydroxylic acid poisoning.
How does that work?
One of the ways it does it is by causing our cells to swell up. In the brain, this swelling raises the intracranial pressure, or ICP, and that leads to headaches, personality changes, behavioral changes, confusing, irritability, and drowsiness. The increased brain pressure is sometimes followed by difficulty breathing, muscle weakness, muscle pain, twitching, and cramping. Also, nausea, vomiting, thirst, and a dulled ability to perceive and interpret sensory stimuli. It can also cause bradycardia, or slow heartbeat. And the cells of the brain may swell so much that the blood flow is interrupted and the person gets cerebral edema, or brain swelling. It can even apply pressure to the brainstem and cause the central nervous system to malfunction. That can lead to seizures, brain damage, coma, and death. And we haven't even gotten to the really scary part.
Oh, man. Okay, I hesitate to ask, but what's the really scary part?
In recent years, the hydroxylic acid craze has gotten so big that it's come to involve some really influential people in cities and towns across America. I'm talking about people like mayors, city commissioners, and city planners. Some of them work in the city water departments. And it's even gone up into the federal government with people in the National Institutes of Health and the Centers for Disease Control getting on the bandwagon. Now, I hate to use the word cult because it doesn't have an objective meaning. It's just kind of an insult word. But some people might look at the situation and say the devotees of the hydroxylic acid craze are behaving like a cult. That's because these people have decided that not only should they regularly consume hydroxylic acid, but that everyone else should too, for their own good, whether they want to or not. Now, you may remember how in the mid-20th century, actually starting in the 1940s, there was a controversy about the government deciding to put fluoride in water. Advocates claimed that fluoridating the water would help reduce tooth decay and cavities, especially in children. But in the 1950s and 60s, there were a lot of conspiracy theorists who thought that this was a communist plot of some kind, and as a result, it caused a huge controversy here in America. It's still a controversy, and some communities have discontinued water fluoridation in their towns. A few medical professionals warned against fluoridation, and it was objected to by health food enthusiasts, Christian Scientists, consumer groups, environmentalists, members of the John Birch Society, and libertarians. In the UK and New Zealand, it's also been opposed by the Green parties. Well, the fluoridation controversy generated so much heat and opposition that the devotees of hydroxylic acid may have learned from that experience, and they definitely do not want the same kind of controversy today. So, since they've decided we should all be consuming the acid, they've decided to add it to the water supply. But they've also decided not to tell us about it. I mean, you'll never find a press release from city officials saying, we're going to put hydroxylic acid in the city water supply. They just do it quietly, like, a secret government conspiracy or something. And it turns out that in many countries and in many communities here in America, when you turn on an innocent water faucet, a really high amount of what comes out is hydroxylic acid.
Wow. Okay. So let's move into the theories part of this episode. What theories are there about hydroxylic acid?
There are several questions we need to look at, including how much cause for concern is there? Just how dangerous is hydroxylic acid in the quantities we're talking about? Who is responsible for the conspiracy to put it in the water supply without telling people? And what should we do in response?
So what can we say about hydroxylic acid from the reason perspective? How much cause for concern is there?
It depends on who you ask. Obviously, the devotees of the hydroxylic acid health craze will say that there's no danger at all. I mean, they not only take it themselves, they want all of us to take it too. So obviously, they don't think there's a danger, at least not in the quantities they're putting into the water supply. And I want to be scrupulously fair here. There are dosages of hydroxylic acid that are safe, as Paracelsus said, the dose makes the poison. Too much of anything, even water, is toxic. And below a certain threshold, nothing is toxic. And, there are doses that have beneficial effects. That's why the World Health Organization put the acid on its list of essential medicines. But you have to be really careful with it, as the WHO also acknowledges. It even depends on how the acid is introduced into the body. For example, inhaling it is really bad. If you inhale even a few drops, it will cause choking or gagging. And if you inhale too much of it, it will quickly become fatal. Also, if it comes into the skin in gaseous form, it will cause instant blistering and second-degree burns. We can tolerate much more of the acid, though, if it's introduced by other means, like injection or drinking it out of the water supply. And, I have to admit, at least most of the time, the amount that people are getting from the water isn't causing any obvious problems. I mean, if people were falling over dead from it regularly, the conspiracy wouldn't be able to hide itself. But who knows how many mild cases of hydroxylic acid poisoning occur all the time without people even realizing it. I mean, who knows how many headaches or cases of lack of concentration or dizziness are due to people consuming too much of the acid out of the water supply. Because it is possible for people to consume too much of it, even without realizing it. Remember how athletes are prone to get dilutional hyponatremia, electrolyte disorders, when they compete. Obviously, they're not trying to hurt themselves, but it happens so often that medical professionals at marathons are trained to look for it. And as we said, it's estimated that hyponatremia has an annual cost of $2.6 billion every year in the U.S. alone. And there are known cases where people have died from too much hydroxylic acid even today, not to mention how it was used as a means of torture and execution in the past. So there is a real danger of accidental poisoning here.
Who's responsible for the conspiracy to put the acid in the water supply?
It's hard to say. I mean, like I think most conspiracies, this one doesn't advertise its existence and it remains faceless. The health craze for the acid doesn't have a leader or a central organization. It's a spread out group of people who've bought into unscientific ideas from the alternative health community. And I should point out that many of the people involved, like city officials, aren't necessarily even members of the health craze. They just think it's a good idea to have a certain amount in the water supply, like fluoride. Like many officials, that doesn't make them fanatical cultists. And it's also not the job of most officials to discuss this with the public. I mean, it would be the job of the high up officials to tell people about potentially dangerous things in the water supply. But someone lower down in the city administration would have to be a person with a high tolerance of risk, a gutsy whistleblower who's willing to lose their job by going out and saying, hey, everybody, the city is putting hydroxylic acid in the water supply. For most city employees, they've heard that having these levels of the acid are safe and that it helps people. And there's no reason for them to disbelieve that, especially since people aren't obviously being harmed by it in an obvious way. So it's natural for them not to say anything. And it's natural for them not to even suspect that there might be a problem.
So what should we do in response to this conspiracy?
Currently, there is no organized movement against having the acid in the water supply. So the first thing to do is educate yourself. Do research and find out how much risk there is or is not, and then determine whether you personally find the risks and the benefits acceptable. Check out the further resources we'll have at the end of the show. We'll have links to a lot of relevant articles. We'll also have a link to an anti-hydroxylic acid webpage so you can see the case against the acid put in its strongest form. We'll even have a link to a video resource that's so disturbing that despite how famous it is, I didn't want to really discuss it in detail in this episode. Also, get educated about your own community and whether the acid is being put in your local municipal water supply. This is somewhat tricky because hydroxylic acid is transparent, tasteless, odorless, and nearly colorless. It's basically indistinguishable from water. You can't tell the difference by looking or tasting. That's one of the things that makes it so easy for people to consume too much without even realizing it. There aren't even home test kits available that would let you distinguish between hydroxylic acid and water. But you can call your city water department and ask to talk to a chemist there. If he's a chemist, he'll know what you're talking about. So you just ask if the city's water has hydroxylic acid in it, and you should get a truthful response.
You mentioned at the start of the show that hydroxylic acid went by a bunch of names in the ancient world, but scientists sometimes refer to chemicals by more than one name. So does this go by any other names in the modern world?
Yeah, some other, like a lot of things, there are multiple terms for this. So some other terms to look for are hydroxyl acid, hydrogen hydroxide, dihydrogen oxide, and dihydrogen monoxide, or DMHO, though the latter isn't well accepted in chemistry jargon. One of the most respected groups, the International Union of Pure and Applied Chemistry, or IUPAC, refers to it in its nomenclature of inorganic chemistry as oxidane.
Okay, Jimmy, so what's your bottom line on this hydroxylic acid government conspiracy?
It's a chemical we need to be aware of. While it's non-toxic and even beneficial in certain dosages, it also can be dangerous and fatal at higher dosages. Many people end up consuming much more of it than they realize, so we need to be educated and we need to be able to recognize the symptoms of hydroxylic acid toxicity. You know, as they say, forewarned is forearmed. Oh, by the way, I should mention that the government conspiracy stuff of putting it in the water supply isn't unique to here in America, and it's not new. On April 1st, 1924, Adolf Hitler was sentenced to imprisonment for his involvement in the beer hall putsch. While in prison, he wrote his book Mein Kampf, which helped him to rise to power. Now, not a lot of people know this, but by order of the German Weimar government, the beer that they were drinking when they set off the putsch contained hydroxylic acid. And whether that's one of the factors involved in setting off the putsch, who can say?
You said that happened on April 1st.
Yeah, in 1924 on April 1st, April Fool's Day.
Oh, funny. That's also today's date.
Yeah.
So, Jimmy, what further resources do we have for the listeners?
Well, we'll have a link to Sam Keen's book, The Disappearing Spoon. We'll also have a link to Wikipedia's article on hydroxylic acid, a couple of articles from there. Also, Planet Gliese 1214b, how it rains on other planets, a newly discovered planet where it rains iron, an article on torture by hydroxylic acid, an article on keratinosis, that's the orange skin condition, one on argyria, the blue skin condition. We'll have the World Health Organization's model list of essential medicines, so you can see where hydroxylic acid fits in that. We'll have an article on Paracelsus, one on hydroxylic acid intoxication, one on hyponatremia, a link to the historic water fluoridation controversy. There's that link I promised to the anti-hydroxylic acid activist group, also an article on the beer hall putsch, and then that really disturbing video that I didn't want to discuss in detail.
Okay. So, folks, what are your theories about the government's hydroxylic acid or dihydrogen monoxide conspiracy? How concerned are you that they have it in our water supply? You can let us know online by visiting sqpn.com or the Jimmy Akin's Mysterious World Facebook page, or send us an email to mysterious@sqpn.com, or send a tweet to @MYS_world with the hashtag of mysterious feedback. So, Jimmy, what's our next episode going to be about?
This Friday, we're going to be talking about David Hahn, the radioactive Boy Scout. So till then, have fun.
Awesome. So you'll find those links to Jimmy's resources from our discussion and links to the mysterious headlines on our show notes at sqpn.com/mysterious. And remember, to help us to continue to produce the podcast, please visit sqpn.com/give. Until next time, Jimmy Akin, thank you for exploring with us our mysterious world.
Thanks, Dom.
And once again, I'm Dom Bettinelli. Thank you for listening to Jimmy Akin's Mysterious World on StarQuest.